All right, now a third example. Notice I changed it to grams. That doesn't change how we work the problem. And the fact that we use a G for grams is why we can't use a small g for giga. We had to use a capital G. So let's go back and look at the chart. We're comparing grams to kilograms, which means this time kilo is going to be the bigger unit. So that means I'm going to do 1 kilogram. It was 3 spaces, so it's still 10 cubed since it was 3 spaces. So I can use 1 kilogram to 10 cubed grams, or 10 cubed grams to 1 kilogram. So our original number was in grams, so that's what we start with. After watching all of these examples between the unit conversion video and this, you should know now that you need a grams down here so that they cancel out, but then that means I'm going to need the kilograms on top. So we start with the number we were given, which is 18.3. We put the 1 with the bigger unit, and so I'm using this fraction. I'll have 1 kilogram to 10 cubed grams. So the way it's set up, grams are going to cancel out, and I'll be left with kilograms. So when I plug this into my calculator, my final unit will be kilograms. So let's see what we get. We have 18.3, and I'm going to divide by 1,000. And that gives me 0.183. And need to make sure that that decimal point is visible. And that's all there is to it. For example 4, I have switched from meters and grams to liters, but it doesn't change how we do it. I'm using microliters, notice the funny symbol, and milliliters. So let's go back to the chart. I'm at milli and micro. So in this case, milliliter is the bigger unit. So in my conversion, that's the one that's going to get the 1. And then it's 3 spaces to micro. So I will have 1 milliliter giving me 10 cubed because it was 3 spaces to get to microliter. So my conversion will be 1 milliliter to 10 cubed microliters, or 10 cubed microliters to 1 milliliter. So we start the problem off, and then we go grab our units. Oops. So our original problem is dealing with microliters. So I need microliters down here to cancel out, which means that I need milliliters right here. So let's put in the numbers. We have 150. No. We have 15.0. And then we have 10 cubed microliters to 1 milliliter. So now notice that the microliters are going to cancel out, and my final unit in this problem will be milliliters, which is what we want. And so I have 15. I don't need to put in the 0.0. It's not going to do anything. I need to consider it for significant figures, but not for typing buttons into the calculator. And I end up with 0.015. but that only has 2 sig figs. Don't forget, even though the calculator doesn't give you that 0, that you have to add it in to make sure that you have 3 sig figs. And it wouldn't have mattered if I had put the 0 in when I typed the 15. Even if I had put 15.0, the calculator doesn't give that trailing 0. You have to put it in if you need it. Don't forget it. For our last example, we're going from kilograms to milligrams. All of the other examples have gone to one of the base units from one of the others, but we're actually going to go through that base unit. And there are 2 ways to work the problem. I will show you a long way, and then I'll talk about another way that you could have done it. So if we go back and look at the chart, kilo is 3 units away from the base unit of grams, and then milli is also 3 units away from the base unit of grams. So let's go back and see what that means. That tells me if I'm doing kilograms to grams, in 1 kilogram I should have 10 cubed grams, and then in 1 gram I should have 10 cubed milligrams. So if I use those 2 conversions, I'm going to have to do 2 steps. So let's pull up our first unit, which is kilograms, because that's what's in the original problem. So as we've done through all of these, I know I need kilograms down here to make them cancel out, but I know what kilograms is to grams. But now notice I don't want my final answer to be grams. I want my final answer to be milligrams, and I need grams to cancel out. So notice when I do that, grams will be gone, kilograms will be gone, and I'll be left with milligrams. So let's go back and fill in all of the numbers. The original problem is 0.123 kilograms. From this conversion, I know that 1 kilogram is 10 cubed grams. And from this conversion, I know that 1 gram is 10 cubed milligrams. Notice my final answer will be in milligrams. So let's pull out the calculator. We have 0.123. I'm going to multiply it by 1,000. And then I'm going to multiply it by that second 1,000. And that gives me 123,000. And that would be your final answer. If you go back and look at the chart, and let's say we wanted to go straight to milligrams, I would be moving 6 spaces. So I could have gone back here, and instead of going through grams, I could have gone straight to milligrams. And if I did that, I would have 1 kilogram down here, but because it was 10 spaces to get to milligrams, I could just do it in 1 conversion factor, and 10 cubed times 10 cubed is going to be the 10 to the 6th, because from your algebra class you should remember that when you multiply powers you add the exponents, and so that should give me the same 123,000. I don't have a preference as to which way you do it. If it's easier for you to remember how many spaces there are from the base unit in each direction, that's fine. Or if you have it totally memorized and you just want to count the total number of spaces, it works also. You can do it either way you want. Good luck with your worksheet on unit conversions and the metric system.